Alright, today we're going to learn a little bit more about balancing equations, and I wanted to review the steps. Remember that we have 7 steps on how to do the boxes method. Now remember, this is for my visual and my kinesthetic learners, so feel free to have out the big dry erase boards and the dry erase crayons so we can work some problems together. Okay? So if you remember, you got your 7 steps. You should have those written down in your foldable that we made in class the other day. And the boxes method. First thing I need you to do is you need to double check your equation. Is it written down correctly? I cannot tell you how many times that I have gone through and tried to balance an equation and had my subscripts wrong or had the wrong equation written down. It'll never work out for you and it'll just make you frustrated. So take 5 seconds at the beginning of each problem and double check. Next thing I need you to do is put a box around every one of your compounds. Then I need you to find the arrow, because that separates your reactants from your products, and draw a vertical line down. This separates visually the left side of the equation from the right. Then I need you to take inventory. So you're going to go through and you're actually going to physically count everything on the left and then everything on the right of your line. And once you got everything inventoried, then you pick the biggest, the baddest, the ugliest looking compound to start with. Now, guys, it's just like triage. You're going to take the worst case scenario at the emergency room because it's going to take the most work. If you decide to go with the small compound, it's going to actually take more work in the long run. Go with the big, the bad, and the ugly. Then you're going to go back and forth between the different sides of the compound, or of the equation, and you're going to add boxes. And after you add boxes, you need to re-inventory. Then you're going to repeat steps 4 and 5 until everything on the left equals everything on the right. And once all of those are equal, you count your boxes. And then that will be your coefficients. Now, just some things to remember. We always put our polyatomics in parentheses. Very important. Helps us balance the equation faster. If there is a hydroxide on one side and a water on the other, the H2O can be rewritten as HOH. And never forget the law of odds versus evens. Guys, if you have 7 oxygens on one side and 3 on the other, if you go through and you double everything, get that 7 to an even number of a 14, makes it so much easier to balance. Alright, so now we're going to work some problems. Okay, I've brought in some problems for us in Paint, and I need you to write them down for me. So you can pause the video real quick and write down the first equation. Alright? Alright, so got your equation written down. Hopefully you're now looking at your dry erase board versus what's on the screen, because you need to double check and make sure you wrote that equation down correctly. That is the number one important thing to do. Next thing we're going to do is we're going to look for polyatomic ions, because I would rather balance 1 versus 2. So I'm going to go through, and if you'll remember, the way we decided if it's got a polyatomic is if there are 3 or more capital letters. So I've got 3 capital letters here. I know that I have phosphate, and I'm going to put phosphate in parentheses. 3 capital letters, hydroxide, parentheses, parentheses, and parentheses. values. So if you'll remember, the second thing we did is we go through and we put everything in a box. So each of my compounds gets put in a box. Okay, easy enough. Then what you do is you come in, you find your arrow. This separates the reactant side from the product side. And I'm going to draw a vertical line. That just helps me separate everything on the left visually from everything on the right. And I'm going to take inventory. So I'm going to come in, I'm going to list, let's see, we've got sodium, Na, and I have PO4, and I keep those together because that is phosphate. It's easier to balance phosphate with phosphate than individual phosphoruses and individual oxygens. And then I've got a potassium, and I have hydroxide. Now I just have to go through and start counting. I have 3 sodiums. I have 1 phosphate because PO4 is phosphate and there's no numbers on the outside here. I have 1 potassium and I have 1 hydroxide. And I'm just going to write my letters down over here for the right side because it all better be over there. NaPO4, and then K and OH. And I count everything on the right side. So I know I have 1 sodium, 1 phosphorus, or phosphate, sorry. I have 3 potassiums, because there's my subscript for potassium, and I have 1 hydroxide. Now I'm on to step 4. This is where I go through and I pick the biggest, the baddest, the ugliest looking compound to start with. Well, that's going to be the number, or that's going to be the compound that has the most numbers in it and the most letters in it. Well, I read from left to right, so I'm going to start over here. Sodium phosphate, Na3PO4. Well, holding up on my left hand, how many sodiums? Well, I have 3 sodiums on the left, and I have only 1 on the right. I need this number to equal this number. So what I'm going to do is I'm going to add 2 boxes. Add a box. And add a box. And fill it in with sodium hydroxide because you can't add half of a compound. Alright, so I'm going to add in my hydroxide. And another sodium hydroxide. And now we have to count. We have to re-inventory. So, how many sodiums do I have on the right now? 1, 2, 3. So I'm going to mark this out. Make this a 3. How many hydroxides? 1, 2, 3. So that becomes a 3. And then I go to the next compound over, which was phosphate. And I had 1 PO4 on the left, and I had 1 PO4 on the right. So that's balanced. I don't have to do anything to PO4. And I'm just going to put a little check mark there. I'm going to put a little check mark by my sodiums. And then kind of look at my sides. What's going on? I have 1 K on the left, and I have 3 on the right. So I know I'm going to need to add boxes to the left. I'm going to add it to where the K is. So I'm going to add 1 box. And I'm going to add another box. And I'm going to fill in my compound, KOH. KOH. Then after I add my boxes, I need to re-inventory. So I have 1, 2, 3 Ks. So now my Ks on both sides are equal. Yay. And then I have 1, 2, 3 hydroxides. And that means my hydroxides are balanced. And once everything on the left equals everything on the right, my last step is to go through and I count my boxes. So how many boxes do I have here? There's 1. Coefficient is a 1. How many boxes here? 1, 2, 3. So my coefficient is a 3. 1, 2, 3 boxes here. Coefficient is a 3. And there's 1 box on the end, and that's coefficient is a 1. Now, please feel free to go back and rewatch how I work these problems. And if you have a question, this is a great time to ask. Raise your hand, and you've got your worksheets in front of you. So good luck. Well, I wanted to show you one more little trick, okay? If you look at this next problem, if you'll remember back on the previous screen, one of the asterisks said that if you had a hydroxide on one side and H2O, water on the other, that I could take this H2O and I can rewrite it as hydrogen hydroxide. So I'm going to erase H2O. You're probably thinking, whoa, 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 Miss Parker, what are you doing? You're changing something up on me. But guys, I promise you, this makes it so much faster and so much easier. So if I do hydrogen hydroxide, I can now balance the hydroxide with hydroxides from the left side and hydrogen with hydrogen on the right. So, happy balancing!